Are you ready for some science? I'm ready for McSalinger science. Yeah! Stand up and shout! Stand up and shout! Stand up, stand up, stand up and lay down. Stand up and shout! Stand up, stand up, stand up and lay down. McSalinger science.
I can't believe you lost your laptop.
I know, those Dravlux. I was on the Trail of Terror, Forest of Fear, and they took it.
Oh, the Oswald Stride Mudslide and Sebastian Bach Rock.
See?
Yeah. Alright. Welcome, guys, to another season of McSalinger,
Science!
where epic metal and science come alive and explode.
Yes.
Today, we are going to go back on what we did at the beginning of last season and experiment with Mentos and Diet Coke. Now, if you remember last season, we did this video that lasted for like 20-25 minutes. It was way too long, we admit, but it still serves a purpose because the reason why it was so long is we wanted to go over the scientific methods.
Step by step.
Step by step. So if you want to review the scientific method, go see that episode. But today we're just going to have fun with Mentos and Diet Coke.
Awesome.
We got 5 different samples here. We are going to measure, obviously, the minty Mentos, fruit-flavored Mentos. We're going to compare that with Tums, Love
it.
Junior Mints, and Sweet Tarts. However, we want to make sure that our experiment is still controlled. So we still have to make sure that we go over variables. So what are we doing here to keep things controlled?
You're always going to want to maintain some control. The way you do that is by having some consistency between your test materials, right? So you'll notice, here's a controlled variable. These are our 5 identical bottles of Diet Coke. What else we got here?
And each sample of each of these in the cups are 17 grams.
Perfect. Nice work. We also decided to kick it up a notch this time, and we're going to use a Geyser tube.
Geyser tube! No, Geyser tube.
Geyser tube.
Geyser tube.
And this
Geyser.
actually serves as a control as well, right? Because we can have a timed release.
Geyser tube!
And ensure that all of the test materials will drop in simultaneously and not get dropped on the floor like someone else.
Yeah, things that have happened before, failed projects. Now, measurements. How are we going to measure what candy or mint has the better reaction?
Well, one thing we definitely want to look for is the height. And that'll be kind of a mixture of qualitative observation, just, stand back and go, whoa, yep, or no, right?
Yeah, I like the yup, no idea.
But we can also try and take an actual measurement of height. We're going to have one of our favorite Steigerites up there on the roof, dropping down a measuring tape to give us a frame of reference. That's one thing we're going to measure.
What's the... Liesgard, right?
Oh, Liesgard.
Liesgard. He's going to be here.
And we're also going to measure what's left in each bottle after the reactions. That's why they're labeled, and that'll tell us how much Coke was actually consumed in the process of the reaction.
So that's going to be a pretty accurate measurement.
We're always accurate.
That's true.
As you can see, the Sweet Tarts line right up into the Geyser tube. 17 grams. So let's hook it up and here we go. Oh, and my car's up there.
So the procedure is unscrew bottle cap, screw on the Geyser tube, then you pull pin and run. In 4, 3, 2, 1, release. Woo! So for that stuff, we got some junior mints. Now, as much control as we've tried to remain Steigerites and retain, you might have some problems here. The junior mints in this beautiful hot sun kind of melted. Their consistency is a little less than solid. Let's see if that plays a role in it. We have the inner minty structures are now exposed. Everything all right, Jensteiger?
Good wasps.
See what we do for science for you kids.
Ready?
All right. let's
Junior Mint Experience. 3, 2, 1. The suspense is killing me. It's coming. Boop.
Wah, 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 wah.
So the delayed reaction there may have impacted the overall effect.
But as you can see, they all fell in.
Oh,
So there is no reaction.
Some fruit Mentos, guys. We're predicting a pretty decent reaction. They've got a kind of a glossy finish. We'll see how that affects the results.
Ready? 3, 2, 1.
Oh, it got me!
This is the Mint Mentos. This is the one candy that you've probably seen numerous experiments for. We know the reaction. Question is, can they beat the Fruit Mentos? Or what was our next one? Sweetie Tots.
My prediction is yes. I think this is going to be dangerous. So respond to safety first. Good luck.
Lifeguard, are you safe?
I'm safe, ready.
You got your goggles on?
I'll close my eyes.
Okay. Oh man, wasps. Ready? 3, 2, 1. Oh, it's.
Wet on the top here.
The fruit one. What?
Nice.
Well, let's go in and measure these pop cans.
McSalinger and Jensteiger mentioned something very neat. They observed this unique thing with the Tums Coke. McSalinger, it's a different color. What is happening with the Tums? Do you know?
All I know is that you've got a lot of acid in your stomach, and usually you take Tums when you've overindulged in pizza, and then you get this acidic reaction. So the Tums are designed to neutralize. We should get that checked out. This to me looks like acid neutralization if I've ever seen it.
Yeah, taking the color right out, taking the acid out of the Coke.
Crazy.
That's crazy. Well, our final, we measured the height of each fountain. Now we're just going to measure how much soda is left in each bottle. So first, we're just going to go in order, the sweet tarts. Tarty. So for the sweet tarts, we have 740 milliliters
Wow.
of pop still left.
What?
Remember, the bigger reaction, the bigger the fountain, the least amount of soda. So this still has 740 milliliters.
So we would expect the other ones with larger reactions to consume more Coke.
Yeah, so there'll be less Coke left.
Got it.
So let's do the others. So, Tums, we've got, it's interesting, it's the same amount. 740, same as the sweet tarts. Now the sweet tart, that means it had a bigger fountain, but this must have lasted longer.
Ah, see, we didn't measure duration.
Right. So it didn't have the height, but it lasted longer. This one here, whoa, the Junior Mints coffee. Oh no, I didn't pour it. because we realized, well, the Junior Mints, nothing, no reaction, so it's just 2 liters. 2 liters of soda still left in the bottle. What about the Mentos?
Well, these two are almost neck and neck. The fruit Mentos have about 590 mils left, and about 611 for the mint Mentos.
Stand up and shout!
So, based on that result, what would you predict would have had the higher fountain?
Well, obviously the fruit Mentos is our champion.
Correct.
So there you have it, guys. The fruit Mentos is our champion, but I would like to state one last thing in conclusion. Obviously, through all these experiments, the Mentos, both of them, had the biggest reaction. And it's also unique that the Sweet Tarts came in second or third, and the Tums came in a close fourth. Junior Mints had no reaction. What do you think is the common theme between the Mentos, Tums, and Sweet Tarts?
Must have something to do with the composition of the candy coating.
Yeah, just feel the surface of each is rough with the Sweet Tarts, with the Tums. The Mentos does not have a rough surface. There's a candy glaze, but what do you think happens when you put this in the coat? That glaze disappears, and what do you get after?
Nucleation sites.
You get nucleation sites, microscopic bits! And that's what creates this reaction. Because carbon dioxide from the soda gets all trapped in those pits.
Yeah, it's got to break.
And then it's just got to break free. How's that sound go?
You had it. That's it.
Yeah.
No, perfect.
So, and that's what happened. And then you get the reaction.
It's pretty cool. Dang. Try this at home, kids, for real. Just don't do it in your house, because that's bad news.
Yeah. There you have it. McSalinger, Jensteiger, to start off another epic season of McStiger Science.
Where science and metal unite.
Unite.